What's up guys, it's your girl Sush back with another science video. This time we're gonna be learning about tension. And this is meant more for just people who know more like how forces work but just need like tension, either review or just they took pre-AP physics but now they're in physics C. And they need some help with tension. They know who they are, and I'm hoping to help them. But if it doesn't work out, oh whoops. Okay, let's try our best though. So I split it up into levels. Level 1, as you can see here, this is just your average block suspended by your average rope. Why am I calling them average? They're outstanding. This is our outstanding block, suspended by our outstanding rope. And our block has a mass m, so that tells us it has a weight. This is the first force vector. It is the force of gravity acting on it. And the weight is just Fg equals mg, which you should know from Newton's second law. If g is acceleration, you multiply that by mass. Alright. Okay, so we have the first vector, but if we just left it at that, that would mean mass m would be accelerating downwards because that's the only force acting on it. But obviously it isn't doing that. We assume that since it's being shown by a string, it's staying still, so F net equals 0, so there should be an upward force, and that upward force is actually supplied by the tension in the string. T is what we'll call it. So you can see, so acceleration is going to be equal 0. F net, it's going to be T minus mg. Mg is minus because since it's going downward, that's the frame of reference that we should be working in by default. So T minus mg is going to equal 0 because F net is equal to 0. And you can just rearrange the terms. T is going to equal mg. Which makes sense if you think about it like a tug of war, you know, between the force of gravity and the force of tension. Gravity is pulling downward, force of tension is pulling upward. It's not moving either way, so they must be pulling with the same force. So T equals mg. Level 2. So level 2, oh sorry, whoops, never mind, that's still level 1. We're still level 1, we're just going baby steps here. We've just added another string, as you can notice, and you can kind of guess what will happen. If you add more strings, you have, so you have identical tension, so T on like a T vector on each side, and mg remains the same. Since now we have two T's going upward, you can guess that since acceleration is 0, F net is equal to 2T minus mg, and so if you solve for T, you get half of mg by 2. This is half of what we had earlier, right? So what the moral of the story is that if you add more ropes, you distribute the force